Everyone, I'm super excited to be here and happy to see all of you here. Thank you for joining for Identity Crisis, the unmanaged world of Azure Managed Identities. My name is Alon Klayman. I'm a security research tech lead at Hunters. I'm the father of Panda, my dog. I'm a soccer fanatic and around a decade in the security and IT industry, doing different roles as a DFIR team leader, penetration tester, threat researcher, and more. And my partner for this talk is Eliraz Levi.
So, hello everyone, I am Eliraz. I am fascinated with logs and forensics in general. On my free time, I am an history geek and amateur tennis player. And I made my first steps in the industry when the cyber term was not so common. We used to call it information security or something like that. So we wouldn't have standing here speaking without the power of the community. Here is only a partial list of great research works from recent years on Azure Managed Identities. Yeah. So, given all those great resources, why are we here? So, when we review the previous works, we saw that the main focus is by nature on attack techniques. And we wonder how we can detect and investigate those kind of attacks. So we hope that during this talk we will be able to share some insights from our work about detection and investigations. So what are we going to cover? We will have a short overview on Azure Managed Identities. Then we will delve into some aspects of JWT access tokens related to managed identities. Then we will see a short attack story that involves abusing of managed identities. Then we will highlight some parts of this attack story and discuss how we can apply and develop detection and hunting thesis for these parts of the attack. And then we will see some guidelines around investigation of incidents that involve Azure Managed Identities. So what is Azure Managed Identity? So basically it's a method or mechanism for Azure resource to authenticate to Entra ID as a principal. So in a word before Azure Managed Identity, when Azure resource, for example, Azure VM, wants to access to some other Azure resource like storage account, we will probably need to have hard-code credentials stored locally on the resource. In this example, the Azure VM. But with the Managed Identity, we can assign Managed Identity to this resource, the VM, then grant it the relevant permissions, for example, a storage account contributor. And then the Azure VM will be able to access the storage account without having the credentials on the machine. It will ask for temporary credential from the IMDS instance, and then we'll be able to access to the resource. So that way, we eliminate the need for stored credentials on the VM. This mechanism is pretty equivalent to the AWS Azure role. So, Azure Managed Identity, basically it's a non-human identity represented by a service principal, but it's a special type of service principal. It is managed by the Managed Identity resource provider, and the number of Azure services that support managed identity increase constantly. And they include virtual machine, deployment script, function app, and a long list of Azure services. The full list can be found on Microsoft website. There are two types of managed identity. The first one is System Assigned Managed Identity, or SAMI. This type is tied to a specific Azure resource, like the VM we saw in the example. And the second type is User Assigned Managed Identity, or UAMI. and this one is created independently and can be assigned to one or more resources, not only to one. So we can imagine a cluster of Azure VMs that run the same application. So in such case, it will be more convenient and practical to assign all of those VM the same UAMI, user assigned managed identity, and give it the permission it needs. As for lifecycle, for SAMI, the lifecycle is bonded to the resource, and deletion of the resource will automatically lead to deletion of the system assigned identity. While for user assigned managed identity, it's independent and must be explicitly and separately managed. So if we return to the previous example, even if we will delete all the VMs in the cluster, the UAMI will be still existing and we need to manage or delete it separately.
All right, now that we better understand what are managed identities, how they can be used, and the types of managed identities, I want to cover one of the main aspects that everybody needs to be familiar with when talking about security of managed identities, the JWT access tokens. Basically, when you ask for access token using the IMDS, you will receive a base 64 encoded token. By decoding this token, both as an attacker as a defender, you can learn a lot of things. As an attacker, if you decode a token, you can understand right away if this is a token that is associated with a SAMI or a UAMI. And also, you can learn a few things about the potential permissions that you might have in this position. So if it's, for example, a Microsoft Graph token, you will know which MS Graph permissions were embedded to this token and about the Entra ID built-in roles that were associated with it. As a defender, it's also super important to understand the building blocks of the JWT access tokens because it includes many fields, and actually each and every one of them can be super useful as part of investigations and detections. Because most of the important ones at least, will also be part of different types of Azure log sources. So by understanding what they mean in the token itself, it will be much easier for you to investigate these kind of things and also to understand about the potential blast radius of a compromised token or a managed identity. So we have two main structures that you need to be familiar with in relation to managed identities access tokens. One of them is the Azure subscription-related tokens, basically all of the ARM tokens, key vault token, storage account token, etc., and the MS Graph token, which looks quite different. Both token types share some commonality between them. You will see, for example, the AUD field, which is basically the audience. This is the endpoint that was used to ask this specific token, and also is useful for you to understand what this token can be used for. And the expiration time, which of course will be embedded in both token types, and of course the UTI. The UTI is one of the most important aspects to be aware of. This is the unique token identifier. It identifies the specific token, not the managed identity, but the specific token that was requested. When talking about each and every one of these token types, each and every one of them has some specific fields that are related only to them. So for example, in Azure subscription-related tokens, we will see all of those XMS fields that you see on screen. Basically, each and every one of them can tell you about the relevant resources and about the specific managed identity. One that I want to highlight at this point is the XMS MIRID field. This field actually very useful to understand if this is a SAMI or a UAMI. In case of a SAMI, you will see the identifier of the resource to which it was attached to. And in case of a UAMI, you will see the identifier of the managed identity itself. Because as Eliraz said before, UAMI is independent, it has its own life cycle, it's not tied to a specific resource. In MS Graph token, you will see some additional fields like the app display name, which is basically the service principal name that is correlated to this managed identity, and also the roles field and WIDS field. The roles field will include the Graph API permissions that were embedded to this token, and the WIDS will include the Entra ID roles, the built-in roles that were provided to the specific managed identity. And by the way, the default one that you can see now on screen, the one that starts with 0997, is basically one that will be always there. It's automatically granted to the managed identity when you create it, doesn't has to do with any kind of special privileges that were provided to it. What you shouldn't look for in JWT access token of managed identities, don't look for RBAC permissions, anything like contributor, owner, reader, or any other granular permissions on the subscription level. They won't be embedded into the token itself. They will be derived as part of the authorization process. And the SCP field, which is very commonly seen in other token types of Azure, but not for managed identities. All right, so now we better understand about the role of managed identity and how the tokens look like and why they're important, and about some of their building blocks. So let's move on to the attack story. And I know we promised that it's a defensive talk and not an offensive talk, and you might wonder, why should we go over an attack story now? But we think that going over this kind of thing will be very useful for us to better explain the detection logics and also the ending thesis that we cover later on. So let's go over it really quickly. We have this made-up corporation named Xona Technologies. Basically, what they do is publish some cool top-notch security research, making sure the defenders out there will stay on top of the game and ready for different types of attacks that are being used by different threat actors. One of the threat actors out there heard about a potential research that is soon to be published and wants to get access to a specific resource group in their subscriptions. The specific resource group is the conf.rg that you see on the right-hand side, and also wanted to do so by gaining access to the initially compromised resource group, which is actually the customer's resource group, because it's more of a publicly facing one. So let's see how we laterally moved, or tried to laterally move, to get access to this specific storage account with a little crown on top, to exfiltrate all the data and delete it later on to make sure that it won't be published soon. All right, so the initial access was gained to a specific virtual machine, as we said before, in the customer's resource group. And by the way, it could have been any other resource that supports managed identities. We selected Azure VM because of simplicity of explanation, but it could have been any other service that supports managed identity, like function apps, app service, etc. So this VM was compromised. The threat actor wanted to check if there is managed identity attached to it. So we used the identity info endpoint. Basically, it's an endpoint that is part of the that can be accessible by accessing to this 169.254 endpoint, the IMDS, to check if there is a managed identity attached to this resource. By the way, it's a very stealthy way to do it because it doesn't generate any logs, nor not even in Azure sign-in logs. After conducting this phase, he basically requested for multiple token types, which is a logical thing to do because this way he can guarantee that he has access to these token types for around 24 hours, which is the lifetime of a managed identity access token. He asked for ARM token, storage account token, MS Graph token, and more. And as we said before, decoding the tokens can be very useful. So he started by decoding the MS Graph token, and he managed to understand that there are no important permissions embedded in it, which is not cool for him. And he moved on to the Azure ARM token. Basically, this token is also very useful, but as I said before, it doesn't include the RBAC permissions embedded in it, so we needed to do some additional discovery phase to actually check what he can do in the subscription. He managed to understand straight away that he has some kind of permissions to the customer's RG and also to the management RG, which is the one that we saw previously in the middle. And he also managed to understand that there is one UAMI that is part of the management resource group, and also did some extra enumeration to find out that there is some kind of key vault named conf.kv that is accessible by a service principal named conf.sp. Very unique names, I know. Anyway, later on, he moved on to attaching the onboarding UAMI, which is the additional managed identity that is identified as part of the discovery phase, to the cPortal VM01, which is the initially compromised VM. Why did he do it? Because this is his way to actually request for additional tokens, because he already had access to this VM, so it's very logical thing to do and very easy for him, as long as he has the appropriate permissions on the resource group, which he had. Before asking for the additional tokens, he had added some NSG rule to allow RDP connection to the cPortal VM01, just in case he loses the access that he initially gained for some kind of network level persistence, and move on to ask for additional tokens, just as he did before with the SEMI, this time with the UAMI, and he decoded the MS Graph token, this time found out that it includes some very nice permissions in it, like the application read-write-all, directory read-write-all, and additional ones. He used it to actually add some a new secret to a service principal, the conf SP that we mentioned before, authenticated as the service principal, read sensitive secrets from the conf KV, and used one of those secrets, which is basically a storage account access key, to access to Xona Research storage account, exfiltrated the data and wiped it out and deleted and did everything that he wanted to do to actually make it, to prevent it from being published. So a lot of cool stuff. Used two types of managed identities and also the regular service principal to get access to this crown jewel, to this nice treasure chest that you see on screen. But did he actually manage to do it? Let's find out.
Okay, so that's what could have happened, but Xona Corp was fortunate enough to have the right detections in place. So let's dive into some selected detection and hunting thesis. So we understand that the detection that related to Azure Managed Identity are quite rarely, and the ones that exist and discussed are basically service-specific. During our research, we tried to map 12 detections, 12 potential detections. All of them, beside one, are service agnostics. And during this talk, we will cover 7 out of these 12. It's important to mention that when we did the research, we test all these detections on dozens of real Azure tenants environments. Okay, so let's dive into the first phase of the attack Alon has shared. The explicit request from the compromised VM for tokens. So the offensive motivation is pretty clear. Is on a compromised VM that the attacker has control over this VM, and he want to know if there is managed identity attached to this VM. In order to understand that, he should query the metadata identity info endpoint of the IMDS. If it returns the tenant ID, then it means that managed identity is attached to the VM. And if the resource has only SAMI attached to it, then the SAMI will be chosen automatically. And the same works for UAMI. And if the resource has multiple UAMIs attached, then the UAMI must be explicitly specified by the attacker in order to move forward. The first detection we want to cover is explicit requests for IMDS from a VM with SAMI. So we need to remember that for managed identity, they request tokens from IMDS frequently as part of the regular operations. Threat actors who gain control over VM may try to request the token explicitly using PowerShell or CMD. And these are the use cases we want to detect. So how are we going to do it? We want to correlate a managed identity sign-in events with a different type of source, the host-based process connection events. The correlation will be based on the name of the SAMI and the host name. The destination IP will be the common IMDS IP. And the process name will be related to CMD or script-based tool like PowerShell or Python. And the host-based process connection events we can use for this detection, we can use several. We can use the Sysmon event code 3, we can use EDR network events, and also Windows event 5.1, 5.6. In this example, we choose the last one. So the query works as following. We are taking the Azure sign-in logs with the category of managed identity sign-in logs. We left join it with Windows event log, and the join is based on comparison of the service principal name, the managed identity name, and the Windows machine name. And we need to remember that for SAMI attached to a VM, the service principal name, the SAMI name, is basically the VM name. We also want to look at process names that are PowerShell, CMD, and other script-based tools. But every good detection idea has its own limitations and disadvantages. So there are some false positive and false negative use cases for this detection. Here we want the main false negative use cases are around the fact that we focus on specific processes like we saw here. And also the event 5156 is known as a verbose log and is not always logged and connected in the environment. So basically this is a detection opportunity we can apply for explicit token request. But as we said, it has its own limitation. In many cases, the resource we want to apply the detection on is not a VM. This detection is service specific. And also, even if it's VM, sometimes the logs will not be collected from or available on the machine. So that leads us to some other detection opportunities we want to share with you. And these ones are mainly focused on the enumeration attempts of the attacker did. The first enumeration with the system-assigned identity, and the second enumeration later on in the attack with the user-assigned identity. So, and the offensive motivation is clear. He is on a compromised machine. He knows it has a managed identity attached, and yet he don't know what are the tokens he can use and utilize using this attached managed identity, so he might like to do some enumeration. So the first detection we can build here is around a mass token types request, a managed identity that initiate multiple token requests for many different token types in a short period of time. That might indicate on enumeration attempt or discovery attempt. But what if the threat actor decides to skip enumeration and be a little bit more stealthy? For that, we can try a different approach and look for some unusual endpoints that were requested by the attacker. So the thing to remember for this detection thesis is that managed identity actions are usually predefined and repetitive. So if suddenly we see a request for token for an endpoint that has never asked before, or at least not recently, it could be suspicious. So how we can detect it? Again, we can look at managed identity sign-in logs under the general Azure sign-in logs, create a baseline over a learning period of pairs of managed identity ID and the target endpoint ID, which basically represent the token, and look for a new pair out of the baseline. So we saw two methods to detect enumeration of managed identity. One is based on mass token type request, and the other on unusual token type request. And these are two approaches we can use parallelly in order to expand our coverage.
All right, so let's move on to the next part of the attack that we want to detect, the attachment of the onboarding UAMI to the cPortal VM01, the initially compromised VM. So, of course, that attachment of UAMI is not by design something that is malicious, but you need to be aware of the fact that threat actors who have gained unauthorized access to a resource group, especially if they have like significant permissions on it, they can assign any kind of managed identity that resides there, basically the UAMIs that are in there, to resources and use them. This is a very common thing to conduct as part of an attack flow for privilege escalation. This is exactly what happened here. If you can see, the attacker actually attached the user-assigned managed identity for the management group to the initially compromised VM from the customer's resource group. So let's take a step back and take a look again at the JWT access token. If you remember, I told you that there are many XMS fields. One additional XMS field I want to touch is the XMS AZR ID. This field is also super useful. It basically includes the indication of the specific resource from which this token was requested. So if you have a UAMI that is attached to 15 different resources, 10 VMs, 5 function apps, or any other combination, you can use this field to actually understand what was the origin of this token request. And why is it so important? Because it's also part of different log sources in Azure. So by knowing what this part of the JWT token actually means, we can use it as part of detection and threat hunting logics. So we use this field to create some kind of UEBA detection or threat hunting based on this field, basically grouping by a specific managed identity, specific UAMI, and creating some kind of baseline of the XMS AZR ID field that are being correlated to this specific managed identity. This way, by looking a few months back, we had the option to actually understand what are the resources from which this specific UAMI actually request tokens. We actually looked for deviations and managed to understand which resources are newly attached resources to this specific UAMI. And in our case, the attacker actually managed to attach this specific UAMI to a resource that doesn't make sense logically or in terms of business need, which is something that you need to always keep in mind when you do this kind of investigation or trying to figure out if this specific alert or lead that was created based on this logic is actually true positive or false positive. Because in our case, as we saw before, the attacker actually attached a UAMI that is part of the HR application, the onboarding UAMI, to a virtual machine that is part of the customer's resource group, a different resource group, a different role. So it's, of course, something that needs to be marked as suspicious and required an investigation. Let's move on to the next phase of the attack. The attacker added an NSG rule to allow RDP to see portal VM01. And we are not going to focus on the specific edition of NSG rule because the attacker could have done tons of things at this point, but we do want to focus on another thing that is related to this phase, which is the fact that the attacker actually used the ARM token that he used before from the initially compromised VM, but this time from his own infrastructure. You can see on screen now that from this point going forward, the attacker mostly used the tokens from his own infrastructure and not from the initially compromised resources. So what we look for in this case is actually cases in which the same token, based on the UTI, which is the field I mentioned before, it will exist in any token type and basically represents the specific token that was requested for this managed identity. It appears under the Azure activity logs, under the identity claims section, and we used it to basically look for cases in which a specific token was used for more than one IP address. How did we do it? Basically, we looked for all of the logs or log entries in Azure activity that includes this XMS MI field that we also talked about before, which is not null, which means this is a field that was populated. This field will only be populated when we are dealing with a managed identity and not with a service principal or any other user. And we looked for cases in which the array of IP addresses was bigger than one, which indicates that there was more than one IP address that was using this specific UTI. Another thing that we actually can use to detect this specific phase of this attack is the usage of a UTI, or basically managed identity token, from a non-Azure IP address. And I know there are some potential for false positive here because there is, like, for example, the Azure Arc service that provides you with the ability to correlate different resources, from example from AWS or on-prem, and somewhat manage them using Azure, which leads to the creation of managed identity in each and every one of them. But in general, the logic says that every time a managed identity is being used, it should be used from an Azure resource, because it should be attached to an Azure resource to actually ask for a token. So what we looked for is actually cases in which the IP address from which the activity was conducted was a non-Azure IP address. This is something that can be done relatively easily because Microsoft themselves published their ranges of IP addresses. They update it on a weekly basis. You can see it in their service tags publication. We created an inventory based on this publication and update it on a weekly basis to make sure that we are aligned with the new version and look for any deviation, basically any cases of activities that are not from an Azure IP addresses. All right, so we also managed to detect this phase using two different logics. Let's move on to the next one, the creation of new service principal credentials for ConfSP. And I know some of you might think now, this is an old and gold detection, the addition of new credentials to a service principal or to app registration was and have been here for a long time now. It's not something that is unique or new. And you're right, we're not going to detect this part. We are actually looking at specific thing that was used as part of this part, which is actually the usage of highly sensitive privileges as part of the MS Graph token that the attacker used. So as I said before, the MS Graph tokens will actually include the specific permissions, both the Entra ID roles and also the MS Graph roles embedded in the token itself. We can see here now on screen the token that was used by our threat actor for the addition of new credentials for the service principal. It included the application read-write all, directory read-write all, and also this user passport profile read-write all. Basically, sensitive permissions that were used by the threat actor to add those credentials. And what we wanted to look for is any kind of activity that was conducted on the MS Graph level, basically using the MS Graph activity logs, that included any kind of sensitive privileges. To do that, we used the MS Graph activity log, but we faced some issues that are related to this specific thesis because we couldn't manage to identify which activities are actually related to managed identities and which are not. Because in the Microsoft Graph activity logs, we don't have all of those XMS fields and all of those identifiers that can help us to identify a managed identity from a service principal or a normal user. So what we did to actually handle this situation is a creation of managed identities inventory, which is something that we use for multiple detections. Basically, you can create this kind of inventory using two methods or somewhat three. I'll explain a bit more about it later. The first one is, of course, usage of any kind of CLI tool like AZCLI, AZPowerShell, etc., to create or basically query for all of the managed identities that you have and create a baseline or managed identities inventory based on this. But what if you don't have this kind of permissions, which actually was our case, because we don't have access to all of our customers' infrastructures to actually conduct this kind of query. And also this is the case for SOC analysts, MSSP sometimes, and also our IR retainers. So in this case, you can actually use the log sources themselves to create this kind of inventory. The main log sources that are related to this kind of inventory, as we see it, is the sign-in logs, Azure Audit, and Azure Activity logs. However, each and every one of them has some kind of limitations. One of the limitations was crucial for us, the limitation of the sign-in logs. Basically, it didn't provide us with the option to identify if this managed identity is a SAMI or a UAMI, and we have detections that actually are very specifically related to the specific managed identities. So we used only the Azure Audit and Azure Activity logs to create this kind of inventory. But it's also important to know that there are limitations for these two as well. For example, in the Azure Audit, you will record only the creations of new MI and managed identities. And in Azure Activity, you will record only the active MIs, which means that if you have some kind of dormant managed identity that exists in your environment for like 3 years now, and was created long ago and it's not active, you won't have it in your inventory. So an option to actually do some kind of combination between both is also a valid way to use. You can basically use this AZCLI tool, for example, to create an initial version using a short leave the permissions, and later on to use the specific data types, the logs of Azure Audit and Azure Activity, to build on top of it and actually expand this inventory over time. This inventory actually allowed us to detect this sensitive graph world usage by managed identities. It's very straightforward. You can actually join between the MI inventory and the Microsoft Graph activity logs to look for sensitive roles that are also listed by Microsoft in their documentation, and you can also do some kind of adjustments based on your selection and add some kind of exclusions or add some additional ones that you find interesting. And by the way, this detection, even though it looks very simple, was super high fidelity detector. We tested it on many, many organizations, and it worked really, really well. And it was super useful to detect this made-up attack, so also nice. So basically, to conclude, we covered most of the attack phases as part of our detection logics. We covered 7 different detections or threat handling logics. We also have a lot of information related to those in our full publication. So if you want to learn a bit about tuning that you can do in your environment, false positive that you can expect, false negative that you can expect, and how to tune them, you can read more about it. And also we have 5 more detection logics that are also available in the documentation. So feel free to read it. We will attach the link in the end of this presentation.
Yeah, so regarding the guidelines for investigation, we will do it really, really quickly. So there are several questions we want to ask. What are the permissions assigned to the managed identity involving the incident? What tokens were requested using this managed identity, etc. We also want to look on a different identifier we can use in order to identify and correlate the activity. So for example, the managed identity ID, the unique token identifier, and the IP. And we want to look in different type of logs. Some of them we discussed during this presentation, and some complementary logs like key vault logs, storage logs, etc. that should be enabled dedicatedly and separately. The following table is a summary of when the UTI and IP can be used and utilized in order to do this correlation and identification. And to summarize, as we mentioned before, managed identity is a good mechanism in general. It increases the overall posture in the tenant, and yet we should be aware on the ways it might be abused and know how to detect such abuses. So we went over an attack story. We highlight some selected detection theses, including how to create an inventory of managed identity based only on logs. And you are invited to visit our website for more details and information. We published 2 research papers. The first one is around adversarial techniques with very informative and useful scripts you can use there. And the second one is around detection and investigation with a sample of queries we ran on real Azure tenants in production. Yeah, feel free to ask our questions after the session. We hope you enjoy it, and thank you for your time.